That's it. That's about it. So,
Okay.
yeah, cool.
Well, let's look at these problems. Now,
Perfect.
notice that it says angles and arcs.
Mm-hmm.
That means we're not going to be dealing with any segment lengths
No.
or arc lengths, probably.
Mm-hmm.
Means everything we're going to be dealing with is degrees.
Okay.
Okay? So, what are you taking these pictures with?
I actually took it with my phone.
Is that an
Are they a
iPhone?
little? It is an iPhone, yeah.
iPhone what?
The 6S?
Oh, okay. Here's what you're not doing.
Uh-huh.
Send them as a large image.
Okay. Do you want me to send it again? Because
No,
I have it.
I can make it out, but
Okay.
I've had enough experience at this to know that when people send it at a small image, the resolution is iffy. And when
Right.
they send it as a large image, the resolution is crystal clear. You can make it out from 100 feet.
Okay.
So I can tell by looking at this that you probably sent it as a small image.
Okay.
But we can still
I'm
do it.
not sure
We
what I
can
did,
still
but
do it.
yeah.
All right.
Okay. Cool.
What's angle, or what is the measurement of arc A?
So would you just do 360 minus 148?
No, 148 is the central angle.
That's essentially.
Notice, yeah, no, you'd be correct if that 148 were outside the circle
Right.
and it was a
But it's not.
measurement from there to there. Then you'd have the perfect answer, but it isn't.
No.
In other words, this fits the situation where you have a central angle.
Uh-huh.
What is the measurement of that arc?
Then the measurement of that arc would be 80.
No, it's 40.
Or no, it's 40.
When you have a
Because
central
it's
angle, it's the same.
right.
If
Okay.
you have an inscribed angle,
Then it's double.
then it's half.
Alright. Yeah. I was.
In other
Yeah.
words, if that's 40,
Right.
that's 20.
Then it's half that.
Obviously, it's got to be less than the central one, right?
Yeah. Right.
So if you ever
Yeah.
forget whether it's half or double, you can always figure it out by just
Okay.
drawing this picture. Because clearly, if the central angle intercepts the same measurement of arc, then the inscribed angle is less, so it has to
Uh-huh.
be half.
Okay.
So if A is 148, what is B?
So if A is 148, then B has to be 70. What is that? 74? Yeah.
Okay.
Cool.
Let me see if I can blow this. Oh no, I got it maximized to the limit.
I could send it again if you
No,
want.
no, no, no. You don't, I don't want you to take the time.
Okay.
Okay. So we have two tangent lines.
Uh-huh.
We know that that angle is equal to what, conceptually?
We know that angle is equal to, it's half of 110.
No, it's half of the big arc minus the little arc.
Okay.
Okay? In other words, it's really the same situation as two secant lines.
Mm-hmm.
Notice that two secant lines, this angle is half of AB minus CD.
Okay.
Okay?
Yeah.
So just because I change them to tangent lines doesn't really change anything in terms of that equation.
Okay.
In other words, whoops, not draw a straight line. I can draw a
That
circle, fine, but
was a perfect circle.
no, isn't it weird? How good I can draw a circle and how bad I can draw a straight line? In other words, this is the same situation as two intersecting secant lines.
Okay.
Theta is equal to 1/2 the big arc that's intercepted
AB minus CD.
Well, it's not really AB. It's, let me put some more letters on this.
Okay.
It's CAD,
Uh-huh.
right? Big arc.
Right. Yeah.
This arc here, the outside of the ice cream cone,
Uh-huh.
minus the inside of the ice cream cone.
Okay.
Okay? Well, that's
Okay.
exactly the same situation as when you have two intersecting secant lines.
Right.
Only the arc's different. It's half that arc minus that arc.
Okay.
But the concept is the same.
Mm-hmm.
So it's not really like it's a separate theorem.
Okay.
It's the same theorem.
Okay.
So let's start with that angle. C is equal to
Okay.
what?
So 1/2 of 110,
No? What's the big arc?
or the bigger arc would be 220, right?
Let's just call it D.
Just D. Okay.
Well, let's call it D for the moment. Minus what?
Okay. So it'd be D minus 110.
Okay.
Okay.
Now, what is D relative to 110? We can figure out D. What is D?
Um, Hold on, there we go. So now it would be C is equal to 1/2 of
Now, hold on. Forget the whole formula. Just look at D and 110. How do they relate?
D and 110. Um,
What's the whole circle add to?
360. So 360 minus 110.
Okay? That's 250.
Okay.
Okay? Now we know what angle C is. Angle
Right.
C is 1/2 of 140, or 70 degrees. Now
Okay.
let's do the ballpark check. Does that look right?
That looks right. Yeah.
It could be a 70-degree angle. It looks a little less to me, but it could be.
It could be,
Okay.
yeah.
Now, they wanted C and D. Well, we kind of figured out D. What was D?
So we know that D is um 250. My bad.
Right. No, yeah. If you
Yeah.
look at the picture,
Yeah.
you can actually figure out, it makes more sense to figure out D first.
Exactly.
Once you figure out D, then C is a piece of cake.
Right. Okay.
These are pretty good problems.
They are. Yeah.
I wish Hansack gave out these problems.
Yeah. Me too.
I was cursing him the other day. I have a
He's
student,
not. He's not a great teacher.
well, I have a student that has him, and she's preparing for his final. And you know what he gave him, his prep material?
What?
He said, take the last 10 quizzes you've taken and look at them.
Uh-huh. Oh my God. What is it? Quite? That's
And
an.
look
Is
at the
that?
word problems. And
Gosh.
the first problem the student gave me was a
Uh-huh.
problem that required a human being to interpret. It was a subjective answer, not a
Oh.
hardcore answer. And if there's one thing you probably know about me by now, it's that I hate math problems that are subjective.
Right.
I want either a correct or an incorrect answer. I
Yeah.
don't want an answer that has to be graded by a teacher, A, B, C, or D, depending on how the explanation sounds.
No.
And that's what Hansack gave them. I could not believe
Oh
it. I left that session so angry at him, I was tempted to call the principal and report him, and then call your mother and say you should report him.
my. Right. I mean.
I didn't. I mean,
Yeah. Is it Quaid that has
yeah,
Yensak? Quaid. Yeah.
yeah.
Yeah. She was talking to me. She said she absolutely hates him as a
Well,
teacher.
she actually probably would have been better off switching to regular geometry like you did.
Yeah, for sure.
It's not that she doesn't have the skills for honors geometry. I think she probably does.
Uh-huh.
But combined with having to have him and honors geometry, it's a little much for her.
Yeah. Hmm.
And I don't blame
For sure.
it. It'd be much for me, too.
Right.
I mean, I can't describe the ridiculously of the problem that he gave them.
Yeah, I
That
mean, that was like,
required an English paragraph to answer.
gosh, that was like him last semester. I mean, every quiz had one of those problems on it.
Yeah.
I mean, yeah, he's not the
No,
most liked teacher at Chatfield.
no, I'm sure he isn't. The
Yeah,
question is how come they haven't done something about it? But
exactly. I mean,
I guess
he
they
likes
lost
failing.
their star calculus teacher
Did they?
to Evelyn. Yeah.
Okay. Who was their
What was her
calculus?
name? She had an article in the local newspaper.
Oh wow.
I can't think of what her name was, but she was an excellent calculus teacher. I had actually quite a few students that she taught, and
Uh-huh.
I was really impressed with her calculus teaching.
Nice.
But
Yeah.
I guess Evelyn hired her away. So.
That's too bad.
Well,
Yeah.
for Chatfield, yeah.
For Chatfield, for Devlin, that's fantastic. But
Yeah, I imagine for Evelyn.
yeah,
All right.
yeah. All
Here's what
right.
they've given us, and they want us to calculate the measurement of arc E.
Okay, so we're gonna do 360 minus 115 for
For
arc E,
what?
right? Arc E.
Hold on. I haven't labeled any of these. Let me label them so we can talk about them.
Okay.
Arc E is not 360 minus 115.
Okay.
The whole circle is 360.
Right. Okay.
So what is arc ABC?
ABC. That ABC would be 78 divided by 2 because it's an inscribed angle, right?
You're right about the second part. It's an inscribed angle.
But it's not half of
Well, is it
78.
39?
No,
Does that
that doesn't look
make
like
sense?
39.
That's almost half a circle.
Yeah, that's not
That's
right.
not 39. Half a circle is 180. So where'd
Right.
you make your mistake?
I cut 78 in half.
What should you have done?
Doubled it.
Okay, so what is arc ABC?
156.
Yeah, 156 from there to there.
Right.
Now you have arc ABC and you have arc CD. The only arc
Oh,
you don't have is E.
right.
So what's E?
So E would be, so we would do 156 plus 115 plus 78, and then subtract that from 360.
Oh, not plus 78. That's an inscribed angle. We're only
Oh,
dealing
that's on
with
the
the
inside, yeah.
circumference of the circle. Don't mix them up.
Okay.
Okay?
Yeah,
156 and 115 adds to 2671.
and then subtract that from 360, right?
Yeah, the only thing
Okay.
left in that picture is AD.
Uh-huh. Okay.
89 degrees.
Yep. Cool. Awesome.
Do not get that.
F would also be 54, because they're both equal to each other.
Hold on a second. I haven't even had time to draw the
Oh, you're good. My bad.
problem. It's all right. Still impressed by my circle.
That's a nice circle.
How
I
can
like that.
a person draw a circle and they can't draw a straight line?
That's me though. I mean, I can't draw a straight line to save my life. I mean,
This segment is the same as that segment.
right. So, cool.
So, what does that tell us?
Oh, that tells us that F would also have to be 54.
Let me label this.
Okay.
Because they didn't label it, and it's kind of hard to talk about it without labeling it. So,
Right. So it's saying that AB is congruent to CD
so what's
or
the
equal.
measurement? Tell me what the measurement of CD is.
CD would be 54.
Okay.
Cool.
And that's 103. Tell me what the measurement of AD is.
The measurement of AD would be 206. Cool.
Now what's the measurement of BC?
And then
This is a geometry problem that has 4 steps in it
okay.
before you can figure out angle F.
Okay. So we would do 206 plus 54 plus 54,
Okay, what do you get?
and then that would be 206 plus 108,
Okay, that's 314,
and then 360 minus 314,
which is?
44.
The last 2 digits have to add to 0.
Right.
So I love the fact that you got 4 as the first digit.
Yeah.
What's the
40.
second digit have to be?
40, 42. Yeah, my bad.
6. They
Is it
have
4?
to
Yeah.
add to 0.
Right. Yeah,
In other words,
46.
when you do this, those 2 have to add to 0 because we're subtracting from 360.
Right.
So this plus this has to add to 360.
Okay.
So you got the first one right, 4, and the second one is the easier one to get, 6.
Mm-hmm.
Okay,
Yeah.
so that's 46 degrees. So now we got the outside of the circle completely measured. Now what is F?
Where's F? Oh, and then F would have to be 54.
Where are you getting that from?
Wait. I'm sorry, so F.
F is an inscribed angle.
Oh, I didn't, yeah, there we, yeah.
The formula for an inscribed angle versus the arc that it intercepts.
Um,
Is it equal? Is it half?
well,
Is it double?
it's doubled.
No?
Or half. It's half if it's on, yeah, if it's an inscribed, it's half, so it'd be 23.
Yeah. And let's say you made the mistake and thought it was double.
Mm-hmm.
Well, double would be 92. Is that a 92-degree angle?
Not at all, no.
So you know you made a mistake. That's
Right.
kind of the secret of math, is using ballpark estimates and catching your mistakes. If you can catch your mistakes, then you'll do a lot better on these tests. Because
Exactly.
you understand about 90% of it, but what happens is you end up making like 1 mistake per problem.
Uh-huh.
And that completely screws you up.
Exactly. Yeah.
Because with math, you really cannot get away with making. In other words, if you have a test that has 10 problems on it, and you only make 1 mistake, you're going to get an A. You make 90%, right?
Right, yeah.
But let's say you have 10 geometry problems, and every one of them has 5 steps.
Mm-hmm.
Well, now if you make 10% mistakes, you're going to miss 4 problems. And you're going to
Right.
get an F. So the more mistakes there, or the more steps there are in a problem, the more precise you have to be.
Yeah.
You cannot get away with even a single mistake if it has 5 or 6 steps in it.
Uh-huh.
So you just have to be really, really careful.
Okay.
All right, so this one.
Number 5.
Give me the formula. Hold on, let me label the thing.
Sure.
Give me the general equation.
So it'd be AB is equal to...
When you start with general equations, start with the angle.
Okay.
Start with 78 degrees. What does 78 degrees equal? Always. Don't mix it up, because when you mix it up, you interfere with your memory process.
Okay.
You always want to memorize something the same way every single time, never differ. Okay? So if I'm memorizing stuff, whether it's this situation or this situation, I'm going to start with the angle. This 30-degree angle is equal to something. This 78-degree angle is equal to something. That's always where you want to start. If you always start at the same place, you won't have a problem. So what's it equal to?
So it'd be 78 is equal to 1/2 of 98 minus CD.
Where are you getting 98?
On the outside.
Well, okay, let's not get to that point yet. I haven't finished drawing.
Okay.
Just the general equation. What is 78 equal to?
1/2 of AB minus CD.
No. AD minus BC, and it's not minus, it's plus.
So AD plus
Measurement of AD plus, because the intersection takes place inside the circle. In other words, what that says is it's the average arc that gets intercepted. This 78-degree angle, well, that's also 78. So it intercepts two arcs. It intercepts that arc, and it intercepts that arc.
Okay.
Well, this angle is the average between those two arcs. How do you get average? You add the two and divide by 2.
Okay.
Okay? So, now let's finish the problem. Now that we have the general equation, which is the most important part, right, 98 degrees over there. Write G here.
Okay.
So 78 degrees equals, wow, hold on a second.
Okay.
I'm not sure they've given us enough information here.
Yeah.
I don't think they have, to be honest with you.
Yeah.
They didn't give us G.
No.
They'd have given us G, we could have solved it.
Uh-huh.
They ask us to solve for G.
Yeah.
But the thing is, we end up with an equation with two variables. In other words, we don't know what AD is, and we don't know what BC is.
No.
And yet, if I start from my general equation, and I fill in AD and BC, they're not even related. I can't even say that G is equal to 98.
Uh-uh.
Ah, I got it. Ah, clever. What's this angle right here? This one right here.
Oh, that one, 180 minus 98.
Minus 78.
Or 78, yeah. I was looking at that.
2.
Yeah.
Now, we got to work with this angle. So 102 is equal to what?
1/2 of arc AD minus arc BC.
No, you have to look at the arcs that are intercepted by that angle. What are they? They're AB
And CD.
CD.
Right.
Well, we know what AB is. It's 98 degrees.
Yeah.
So I can fill in 98 for that. That leaves the only thing to answer is G.
Right.
Now I can do that math. That's just an algebra equation with one variable.
Let's G. Yeah.
So this one was a little tricky. We had to actually figure out the linear angle.
Right.
And our first clue should have been the fact that they give us this measurement and this measurement, which are the angles intercepted by that angle and that angle, not our 78-degree angle.
Right.
So we really need to start with this 102-degree angle as our starting spot.
Right. Okay.
I actually did this problem earlier.
Cool.
That's the center of the circle.
Right.
Not the way I've drawn it, but trust me.
Uh-huh. Okay.
Angle H intercepts from there to there, right?
Right.
So we have to figure out that distance.
Right.
Arc measurement of from there to there. Well,
Okay.
if this is the center of the circle, and this is a diameter line, which it is in the original drawing.
Uh-huh.
What's the measurement from here to here?
180.
Okay. So what's the measurement the other way?
So the measurement the other way would have to be, to
180 also.
180. Yeah, because it's just the other half of the
Exactly. It's the other half.
semicircle.
If this whole thing between my hash marks,
Uh-huh.
excuse me, would have helped
No,
if
you're
I'd drawn the thing in perspective, but I didn't.
No, it's all good.
This whole thing has to be 180. What's the measurement from here to here, given that they've told us that that's 26 degrees?
You just do 180 minus 26.
Yeah, so what is it?
Which is 158.
Remember, the last two digits have to add to 10.
Or 154, my bad. Yeah.
You see how easy that is? In other words, you got the 5 right,
Mm-hmm.
then just make sure that last digit adds to 10 with 6.
Uh-huh.
Okay? Now,
Okay.
we know that arc, and that arc is the exact arc that is intercepted by angle H.
Yeah.
What's angle H?
It would have to be 77.
You got it.
Cool.
Wow, what is this question doing on here?
Oh, just
What's the
circumference.
circumference of that circle?
2 pi r. So it'd be 2 times 3.14 times 23.
No, leave it in pi. Oh,
Okay, so, okay.
unless the problem says convert to a decimal, always leave it in pi.
Right. So it'd just be 46 pi.
Yeah,
Cool.
never convert that thing unless they tell you to.
Yeah.
This is a good problem here.
Cool.
All right. You have to know.
Oh, that's an inscribed angle, right? So just...
And there are 5 steps to this problem.
Oh, there is, yeah.
Well, it's not obvious that there are, but there are.
Well, because it shows the length of xy is 7 pi, which means you have to...
Well, they're asking for the area, and they've given you the arc length of 7 pi. Okay?
Yeah.
Now, how do I know that's an arc length and not a degree measurement? Well, first of all, it's got pi in it and centimeters.
Right.
In other words, if I cut that piece of string there and there and stretch it out and measure it, it's 7 pi long.
Uh-huh.
Okay, that's what the length of arc XY means.
Okay.
All right, so the only way we're going to solve this is to start with a general equation that relates this angle, well, no, that relates this arc length to circumference.
Okay.
What's the general equation for arc length?
Arc length is equal to 1/2 of...
No.
That's
Think
not,
for a second. Think for a second. It's equal to the circumference times what?
Circumference times...
The percentage of the circumference that that arc length represents.
Okay.
Well, how many degrees is that arc length?
126.
Okay. If that's 126 degrees, what percentage of the circumference do we have?
We have...
What's the full circumference?
360. So you do 360 minus...
No.
Yeah, over 126.
6 over 360.
Yeah.
That's about a third. 12 over 36 is about a third. That
Yeah.
looks to be about a third of our circumference. So we're
Yeah.
definitely in the ballpark.
For sure.
Okay? Now,
Okay.
arc length they've given us. Well, first of all, let's do one more step.
Okay.
What's the formula for circumference?
2 pi r.
And they've given us the arc length.
Uh-huh.
It's 7 pi.
Yeah.
What does that allow you to solve for?
That allows us to solve for... Well, that's to solve the radius.
Yeah, that's the only variable there.
Yeah.
So we can solve for the radius. Remember what the question is. What is the area?
Right.
General formula for area?
Pi times radius squared.
So once we solve for r, we'll have the area.
So now we have...
I don't need you to necessarily do it.
Yeah, those would cancel out.
Yeah, I mean, you can solve for r. If you can't solve for r, we need to go back and study algebra.
Right.
But I'm assuming you can solve for r.
Yeah.
Once you solve for r, now we're going to be able to figure out area.
Right.
So, how many steps were there to this problem? First of all,
5.
we figure out that arc length, 126. That's step 1.
Right.
Then we had to figure out that, step 2. Then we had to figure out radius, step 3. And once we had radius, we had to figure out area. That's step 4. Excuse me 1 second, Dylan. Let me go shut my dog up.
No problem.
Come here. What's going on? Come here. Over here. Come here. Come on. Yeah. Now she wants to sit in my chair. So that simple looking problem was a terrific geometry problem. That forced you to know about 4 different theorems in order to solve the problem.
Yeah. Cool.
Number 9, how do I solve for x?
It would just be 7x minus 8 is equal to 4x plus 7.
Yeah, piece of cake.
Yeah.
Solve it.
And then we would have 7x plus 15 is equal to 4x, 3x is equal to 15, x is equal to 5.
Okay.
Cool.
And number 10.
Alright.
What's the
And then this one,
formula that applies?
outside part of the circle times the inside part?
It's
Or is it the opposite?
times the whole thing.
Times the whole thing.
That's
Okay.
the difference. Here, let's examine that, because most people make that mistake.
Okay.
When I have 2 intersecting chords inside the circle, it's
Uh-huh.
A times B equals C times D.
Okay.
But when I have two things that intersect outside the circle, it's never that.
No.
Notice what I have is a tangent line intersecting with a diameter or a secant. It's not even a full secant line.
No.
What do I know about that triangle?
Has to equal 180.
It's a right triangle.
It's a right triangle.
In other words, this is a right angle, always. A tangent line makes a right angle with a radius line.
Okay.
It's not a tangent line if it does not. Now,
Yeah.
the way I drew it wasn't exactly right, but if it's drawn properly, a tangent line always makes a right angle with the radius line, which in this case, that's x.
Right.
This is 63. That's also x because all
49.
radiuses are equal. That's the segment length outside the circle from there to there.
Oh.
What's the equation that applies here? You need the general equation.
General equation would be 8 times.
We're talking segment lengths here.
Okay.
In fact, every question up through 8 was all about degrees.
Yeah.
But 9 and 10 are more segment lengths. In other words, when we did 9, we set this segment length equal to that segment length.
Right.
Okay, well this is a segment length problem. So we have these two lines and those two lines, and we know that's a right triangle. Give me Pythagorean's theorem.
A squared plus b squared is equal to c squared.
So how does it apply here?
So it would be x squared plus 49 squared is equal to 63.
The other short side of the right triangle.
X.
63.
Oh, that's right, because that's, because it's opposite.
Two short sides of the right triangle. There's one. They're the sides that make up the right angle.
Right.
So you square both of them.
Okay.
And that's equal to the hypotenuse squared. What's the hypotenuse?
49.
No, 49 is the measurement from here to here.
Of x times 49 plus x.
49 plus x.
Just 49 plus x.
49 plus x. That's the hypotenuse length, and we have to square it.
Okay.
Okay.
Cool.
Now we have an equation with only one variable. We know how to solve that.
Yeah.
That's going to turn into a quadratic, and we're going to have to solve the quadratic equation. And it's not even going to turn into a quadratic. Watch what happens here.
Okay.
Well, I don't need to expand. Well, I guess I do. Do you have a calculator? Here, I got one.
Okay. Yeah, I have.
3 times 63 equals 39.
3,969, yeah. That's a big number.
What's the right side equal to?
49x.
No. It's 49 plus x quantity squared.
Oh, I didn't square it. That's what I do.
Square. You have to multiply it by itself.
Right. So it would be 49 plus x squared.
49 squared plus 2 times that, which is 98x, plus x squared.
Okay.
Okay? Now, notice that the x squareds cancel with one another.
Yeah. So you're just left with 3,969 is equal to 49 plus 98x, which is just like a simple algebra problem.
Very simple linear equation, only it's 49 squared. So you still have to square 49, subtract it from this number, and divide by 98, and you'll get x.
Cool.
Okay?
Okay.
So, and the reason this is different, in other words, the reason this does not follow the other stuff is because we don't have a secant line here. If I were
Right.
to extend that to a secant line, well, now I know what that distance is, and now I could use the equation that says 63 squared, the tangent line squared, is equal to 49 times the length of the secant line, which is 49 plus 2x.
Right.
So I could also solve it that way. But this is kind of a unique problem where it only goes to the center. In other words, what do you call this line here? It's not a secant line. A secant line is one that starts outside the circle and connects with 2 points on the circle. Okay?
Yeah.
So the only thing we can really use here is the Pythagorean Theorem. And there's only one variable, x. So as long as we get the Pythagorean Theorem correct, we'll solve it. Now, this other way, where I extended it, making it a secant line, and knowing that that also has to be x, well, now you can use the geometry theorem regarding tangent lines and secant lines.
Yeah. Okay.
All right.
Cool.
Is that a good place to stop?
I think, yeah, that's a good spot.
Yeah, these 45-minute sessions seem to be working pretty good. I'm not going to mess with them. And I'm only charging you for 45 minutes when we do just a 45-minute session. So,
sure.
No, these are excellent problems, incidentally. Hansack could take a lesson from these 10 problems.
For sure. Mr. Magus he's a good teacher.
What's his name?
Mr. Magus, Jeff Magus.
Magus? Okay. Well, remember that because, yeah, I love your review problems. Every one of your review problems tends to test a different theorem, and then the harder ones test like 4 different theorems.
Right.
So you really have to know your stuff to answer these problems.
For sure. Yeah.
All right. When is your final?
Thursday.
All right. Let me just check our schedule here and make sure that we are scheduled correct next week.
Sure.
I don't have anything down for you, Dylan.
Okay. Could we schedule some?
Sure. Tell me what.
Let's just do that right now. So tomorrow's Monday, so would 6:30 tomorrow work?
Here's my schedule already for this week. Anything in this color is scheduled.
Okay.
And I've blocked out this just because that's 3 hours in a row, 3.5 hours in a row. I give myself a little time before and after. So
for sure.
Before 3, after 7:30.
Sure. Would 8 o'clock work?
Yeah.
Okay. Perfect.
You want me to block you off for an hour and we can do however much you feel like?
Sure. Yeah. Like we've been doing. That would work.
This works pretty good. I think actually 45 minutes is almost the perfect time for you.
For sure.
So I'll schedule that.
Perfect.
When else?
And then Tuesday we could do, because I practice till 8, 5 to 8.
Okay.
Would 8:30 work?
Yeah.
Cool. Yeah, we could do 8:30, and then we could probably just do like a half hour for that one.
Okay.
Since it's kind of late.
I'll do that.
Perfect. And then
else?
Wednesday at 8, would that work? Perfect.
And that'll be it.
Awesome. Sounds good.
Thursday, yeah.
Yeah.
It's like I'm going to be busy until Wednesday.
Okay.
I don't think this guy, I think he's had his final before Thursday, so I don't even think I'll have him. So.
Okay.
Yeah, so Wednesday my vacation comes.
Perfect.
All right,
awesome.
Dylan, you have a good weekend.
Thank you. You too. Thanks for coming.
Talk to you later. Bye-bye.
Sounds good.